All right, section 6.6, Math 60. Here we want to solve the equation for specified variables. Like here, before I go over this, let's look at this one. Let's say you have a formula which is, we want to solve the equation which is 2x equal to 5. When we ask you to solve this equation for x, what would you do? Since you want to find x by itself, you divide both sides by 2. Then you say x is 5/2, correct? So we have an equation which is the distance formula, which is the distance is equal to the rate multiplied by time. This distance in physics, it tells you that distance by itself is equal to the speed or rate multiplied by time. What if I want to find time by itself? Then we need to divide both sides by r. So time would be d over r, okay? It's very similar to this. If you want to solve it for x, whatever number sitting next to x, you gotta get rid of it. That's how it works. Or let's say here, I want to solve this for the value of r. Then you divide both sides by t if you want to have r by itself. See? So in this example here, this equation is given. So in this type of problem, normally we give you the equations. So you don't have to know where that equation is coming from or what the letters are. But this equation is the letter P is equal to V minus I divided by S. And we want to solve it for I. So what I do is first I give a denominator of 1 and we cross multiply. When you cross multiply, you take the P and multiply by S equal to V minus I times 1. See? And since we are solving it for I need to move I to this side. So minus I become positive I. And then move PS to the left, right, which make it like a minus PS. See, I is by itself. That's what we're asking. When we ask you to solve for a specified variable, here we ask you to solve it for I. That means you have to find I by itself. Like this one, this equation is given. We want to solve it for value of y. Okay? To solve it for value of y, what you could do, you could, first you could take a common denominator here, write it as y equal to y is s times r, and then here you have r plus s, okay? And when you multiply this, or cross multiply, then you have r plus s times y is equal 1 times s times r. But since we are solving it for y, we don't need this parenthesis sitting next to y. So we divide both sides by that r plus s. So in that case, y is by itself. See, SR over r plus s. So what I did here, I solve equation for variable of y. Like this one, we want to solve it for, letter of h. So you have s, let's say s over 1 is h times a plus r over 2. So when I cross multiply here, I have 2s is h times a plus r when you do cross multiplications. But since you want to solve it for h, then you divide both sides by a plus r. So in that case, you have 2s over A plus R is equal to the H. See, that's how to solve the equation for letter H. Means H has to be by itself. And this one I have A is MQ plus Z over 8, and we want to solve it for letter Q. So again, what you do is you cross multiply. You have 8A is MQ plus MZ. And remember, we are trying to solve it for Q. So we move MZ to the other side. So positive MC become negative. So then you have 8A minus MZ is equal to MQ. Okay? And since we're solving for letter Q, we don't need this M. So divide both sides by M. So then Q is 8A minus MZ divided by M. So sometimes when you separate them, you could also write it as 8A over M minus MZ over M, which is 8A over M minus Z. You could also write it like that, okay? So that's how to solve the equation for a specific letter of, for the letter that is specified in the problems. Now here is a problem number, let's see, that was problem number 4. So we work on problem number 5. See, like here you have okay, this is a formula in the chemistry. We want to solve it for V2. Okay. So when I cross, so this is what I have. I have P1, V1, T2. When you cross multiply, it's P2, V2, T1. When you cross multiply these two, that's what you get. But since I want to solve for V2, then I divide both sides by P2, T1. I want to solve it for V2, right? So in that case, it's to cancel. So V2 is by itself. So V2, it's P1, V1, T2 over P2, T1. Again, our goal is to have letter V2 by itself on one side. I want to solve it for letter T. So this is like a big Q is AT over A plus T. So we cross multiply again. So we have AQ plus TQ is AT, right? Since we are solving it for letter T, we need to collect all the T on one side. So I would move this to the other side. In that case, I have AQ is AT minus, let's say QT instead of TQ, okay? Now these two, they both have letter of T. So if I factor T out, what is left is A minus Q on this side and AQ on that side. And then I divide both sides by A minus Q. So that's what you get. You get T is AQ over A minus Q. See, so I try to have T by itself on one side. Now here we want to solve for B. So is alpha is 12B over K, or just say alpha over 1. So we cross multiply. It's 12B is alpha K. And since we are solving it for B, we just divide both sides by 12. So B by itself is alpha K over 12. So the first 7 problems are just discussing how to solve the equation for specified variables. This problem is also solve the equation for letter G. So we get all these letters here. Again, to solve it for G, we cross multiply. So it would be sigma G is 5m alpha, and then divide both sides by this sigma to just have G by itself. All right. Now, number 9, these are some word problems that Sally can paint the room in 7 hours, while it takes Steve 9 hours to paint the same room. So there are 2 people. One person, Sally, finished the job in 7 hours. The second guy, Steve, finished it in 9 hours. If they both work together, how long would it take? You know, I create a formula that in this formula, A1 and A2 are when people work by themselves, alone. This is if people work alone, and A is when they work together. Okay? So like Sally works 7 hours by itself. So that would be 1 over 7. Steve works 9 hours by itself to finish the job. What is A? A is when they work together. All right. So before I continue with this problem, let's look at this one too. 3 postal workers can sort a stack of mail in 30 minutes, 35 minutes, and 210 minutes, right? What if they all work together? So here there are 3 involved, is A1, A2, A3, and then A. Okay, so you have all these 3 working together to finish the job. So in that case, it's 1 over the first post worker 30 minutes, the second one 35, and the third one is 210, and A is when all 3 work together. Okay, So I want you to understand similarity of these two problems. This is like 2 are involved, this is 3 are involved. Again, A is when they all work together. Now, so for the first one, we have this. 1/7 plus 1/9 is 1/A. So for me to get rid of the denominator, there are 3 denominators, 7, 9A, right? So or is the common denominator is 63A. 7 times 9 times A, 7 times 9 times A is 63A. So I multiply every fraction by 63A, 63A. I'm doing that to get rid of all the fractions, or I'm sorry, all the denominator. So when I put 63A here, 7 goes to 63 is 9, 9 goes to 63 is 7, and A cancel. So see, you don't have any more denominator. 9A plus 7A equals 63. So 16A is that, and A is 3.9. So it takes 3.9 hours if they both work together. One by itself, the first person can finish the job in 7, the second person can finish the job in 9, but when they work together, it takes 3.9 hours. Problem like that is very practical too. Now, in post office, one person can finish the job in 30 minutes, the second person can finish 35, the third person, it takes a long time, 210 minutes to finish the job. What if all work together? So look at, the denominator is what? 30 times 35 times 210 times 8. That's your denominator, the common denominator. So why don't you multiply every fraction by this? Like this one is 30, right? Okay, let me see. So the common denominator is this, 30, 35, 210, 8. The first one already has 30, but it doesn't have 35 and 210 and 8. So you put that 35 and 210A here. The second one already has 35. So it needs 30 and 210 and 8. 30 times 210 times 8. The third one already has 210. So you just need 30 times 35, 8. 30 times 35, 8. And then the last one is just 1. So you need all things. So you put that one here, okay? So when you cancel all those, then you get this 7350A, 6300A, 1050A equal that, and that give you the A equal 15. Means all 3 of them, if they work together, it takes 15 minutes to finish the job, if they all work together. This problem number 12 also is kind of similar to Dan's other problems. One hose can fill the fish in 55. 2 hoses together can finish. So if I write a formula as like 1A1 plus 1A2 equal 1A, remember A1 and A2 is if each individual work by themselves. One hose can fill in 55 minutes, okay? It doesn't say how long does it take for the second one, so it's unknown. But when they work together, if 2 hoses can fill together, it's 30 minutes. So it's 1/30 minutes, see? In this case, A2 is unknown. How long does it take for the second hose to finish the job? And that's how we solve that. So the unknown is 1/A2. So I'll take 1/55 to the other side. So it's changed to the negative. Now, the common denominator is this. The common denominator is 30 times 55 times A. This is a common denominator. So if I take each fraction and multiply by that, see how I put it everywhere? Then the first one, A2 and A2 cancel, the second one, 30 and 30 cancel, 5, and so that you end up having no denominator. And when you solve that, A is 66. I mean, when they want the second host can fill the tank in 66. Then we deal with this kind of problems. Number 11. So in number 11, do you understand that if there is a river, let's say there is a hill, and the river, and the current is in this direction, of course, from downstream. So if somebody is swimming from A to B, the rate of the current is always added to the rate of the swimmer. So let's say if the rate of the swimmer is X and rate of the current is Y, when you go in these directions, the actual rate is X plus Y. But when you swim against the current, then the actual rate is X minus Y. Why? Because the current rate is against you. So when you swim with the direction of the current, then you go faster. X plus, so X is like a swimmer, and Y is the current. Okay, so it's X plus Y and X minus. So we use this idea here for the problem number 11. So when you go downstream, its speed is X plus Y, and it's said in the problem downstream is 30 miles. When you go upstream, the actual rate is X minus Y. And what is X and what is Y? Y is the rate of the current, and X is rate of the swimmer or boat or whatever. So the distance formula is the distance is rate multiplied by time, or time is distance divided by rate. Like when you drive 55 miles per hour is just the distance divided by time, which give you the rate. So in that case, time is 30 over X plus 3. Y is given in the problem. Is the rate of the current is 3. And the time of upstreams also is 20 over X minus 3. And the problem said the times are equal. So if you put these two fractions equal to each other and do the cross multiplications and work on this, that give you the X15. So rate of the swimmer, or if there is a boat, rate of the boat is 15. Again, X and Y. X is rate of the swimmer or rate of the boat. Y is rate of the current. Rate of the current in the problem is given is 3. That's why we put that 3 here for the Y. We also have problem number 14 is very similar to this. Let me see if I find this. Number 14. Number 14, it said a plane flies 425 miles with the wind and 350 miles against the wind. It's very similar to the current. 425 miles with the wind and 350 miles against the wind. Time is the same length of the time. If the speed of the wind is 15, find the speed of the plane. So in this case, when they go with the wind is x plus 15. Remember, 15 is the rate of the wind and x is rate of the plane, which is unknown. So the actual rate when it's with the wind is x plus 15, and when you go against the wind is rate of the plane minus rate of the wind. Time, the distance are given. So again, time is distance divided by the rate, distance divided by rate. Time is equal to time is given in the problems. So you said these two equations equal to each other. When you cross multiply, you end up having 155. This is the rate of the plane. And then we have problem number 15 here. He said the denominator of the fractions is 5 more than the numerator. So you have a fraction which has a numerator and denominator, okay? Numerator over a denominator. It said denominator is 5 more than numerator. So that gives you these equations. Denominator is 5 more than the numerator. Then it said if you, both numerator and denominator, if you subtract 2 from numerator and denominator, then that is equal to 7 over 12. So they are saying if you take 2 away from numerator and denominator and write the fractions, then it's 7 over 12. See? So you have these two equations. We understand that d is n plus 5. So you take this d and you substitute here. And that gives you that. 5 minus 2 is 3. So you see, I end up having one equation with one letter of n. So when I cross multiply, I get this. And then finally, I find the n. N happened to be 9. When you have the n 9, then you put it back here. 9 plus 5 is d. Okay, so n over d would be 9 over 14. So again, in these problems, first they indicate that denominator is 5 more than numerator, and then they also say that if you take 2 subtracted from numerator and denominator, the ratio is 7 over 12. So these two are given in the problem. But these two equations, since this one, it gives you d in terms of n, I'll take this n plus 5 and substitute for this d here. See? And 5 minus 2 is 3. I end up having just one equation with letter of n.